Good morning, my viewer. As I told you, we shall be continuing with a series of these videos, and this morning we are going to cover graphs of sine theta, cos theta, and tan theta. As I said, in trigonometry we shall be building concepts. You remember, sine theta is equal to y over r. Now when we assume that radius r is equal to 1, we shall have the expression y is equal to sine theta. And once we draw our graph there, we're going to be plotting values of y against theta. Remember, y is equals to sine theta. So we shall label our theta 90 up to 100 up to 360. And so we shall keep plotting. When theta is 0, sine theta is 0. When theta is 90, sine theta is 1. And when theta is 180, sine theta is 0. And when theta is 270, sine theta is equal to -1. And when theta is equals to 360, sine theta, which is y, is equal to 0. And that gives us our graph there, which we call the sinusoidal graph. You will realize from the graph that the maximum sine theta, or the maximum value of y, is a +1, and the minimum value of y is -1. Any value outside that range will give us wrong results. It will give you a math error on your calculator. Okay, so you label our graph, of course. Now for the cos theta, we shall do the same thing. Remember, cos theta is equals to x over r, and therefore x is equals to cos theta y, because r is equals to 1, which is our radius. And therefore, once we continue plotting there, cos of 0 is 1, cos of 90 is 0, cos of 180 is -1, and they continue in that series. You can prove these on your calculator, just like I'm proving mine aside there, as you can see. And so once we draw that, it is also a sinusoidal curve, or you could call it a cosine curve, but it is just simply out of phase. Its maximum is also 1, and its minimum is -1. Then finally, for the tan theta, it is a little complicated. You'll observe as we continue. You have named your axes and all that. So we have some situation here whereby we are having an invalid input for tan 90. Tan 90, actually tan theta has no limit. Are we okay? It has no limit. The maximum tan is positive infinity, and the minimum tan is -infinity. So it gives us what we call an asymptote. An asymptote is a line to which a curve tends to, but never crosses that line. That's why our line is bent at some point, and it continues on the y-axis up to infinity. And then, of course, for the other side, angles in between 90 and 180 are negative for tan. Why? Because in that quadrant, only sine is positive. So our maximum tan is going to be positive infinity, and our minimum tan is going to be -infinity. And those are our graphs. So I've drawn my graphs there for sine theta, cos theta, and tan theta. This is an examinable area. One of the years in UNEB, they asked people to draw a cos curve. I can't quote the year correctly, but you can go and quote it. You can go and look at that number. But they were simply testing our knowledge of trigonometry. So every time you have the sine, cos, and tan of a positive angle, you'll get a positive sine, cos, or tan of that particular angle. However, for a negative angle, for sine, you'll get negative sine that angle. For a cos of a negative angle, you'll get positive cos that particular angle. And for a tan of negative angle, you'll get a negative tan that particular angle. That will mark the end of our lesson today for graphs of sine theta, cos theta, and tan theta. Thank you very much. I hope to see you in the next tutorial. Thank you.